Hi everyone, in this video I'll be talking about design guidelines for milling. So what is milling? Milling is a cutting process that uses a rotary milling cutter to remove material from the surface of a workpiece. It is usually moved perpendicular to its axis so that cutting occurs on the circumference of the cutter. DFM is basically the practice of designing products keeping manufacturing in mind. Design for manufacture means the design for ease of manufacture for the collection of parts that will form the product after assembly. Now let's talk about rule-based design guidelines for milling, which is a machining process. We must avoid sharp internal corners. Rounded corners provides number of advantages such as less stress concentration on part and tool. When designing a three-edged inside corner, one of the inside edges must have the radius of the end mill. So as we can see in this is an internal sharp corner which is not recommended. This one is recommended. If the sharp corner cannot be avoided and is required for mating relationships, a relief hole should be drilled first and then milling should be done. In this photo, we can see the relief hole so that the machining can be done easily. We should avoid deep radiused corners. Milling areas must be designed such that longer end mills are not required to machine it. Recommended maximum length to diameter ratio is 3:1. In the first figure, the depth is more as compared to length and breadth, so it is not recommended. Whereas in the second figure, depth is not very large and it is possible to machine it. Now I'll show you a video in which side effects of deep milling is shown. If the deep radiused corners are extremely necessary, clearances should be provided. The following clearances can be implemented. So uh, in this one it is not recommended as the milling cannot be done easily. This has a relief angle, so it is possible to machine with this. It has a clearance and it also has a clearance. For surfaces with high degree of flatness, bosses should be used to save time and money. This is not recommended and this one is recommended as it has bosses. Narrow and deep holes should be avoided because longer tools are more prone to breakage and chip removal becomes difficult, especially when the pockets and slots are blind. So this type of slot is not recommended. The milling cutter requires sufficient space to move. Therefore, narrow regions in pockets must be avoided so that there is space for milling cutter to move. We must use standard side radius and bottom radius, which will ease manufacturing of milling features with angular milling faces and impossible pockets should be avoided. As we can see in the first figure, the angle is less than 90 degree and milling is only possible with 5-axis machining. So this must be avoided. In the second figure, it is impossible to machine this with a 3-axis machine. Same is the case with the third figure. Tool accessibility is also a very important feature. The feature should be accessible to the cutting tool in the preferred machining direction. In this, the counterbore hole is opening inside another pocket and it is very difficult to machine them. Outside radius requires a foam relieved cutter and a precise setup which are costly. Therefore, chamfers must be preferred over radii. Therefore, this first figure is not recommended and the second one is recommended. To summarize the design guidelines, Sharp internal corners should be avoided. Relief holes for necessary sharp internal corners should be used. Deep radiused corners should be avoided. Clearance for necessary deep radiused corners should be provided. Bosses should be used for surfaces with high degree of flatness. Deep narrow holes should be avoided. Narrow regions in pocket should be avoided so as to provide sufficient space for milling cutter to move. Standard side radius and bottom radius should be utilized. Angular milling faces and impossible pockets must be avoided. Designs should be such that the features are readily accessible by the tool, and chamfers should be preferred over radii. These are the references. Thank you.